you by thesis123.com. I learn and teach online.
Here's the next question, number 52. The gain at the breakaway point of the root locus of a unity feedback system with open loop transfer function g of s is equal to ks by s minus 1 into s minus 4 is a, b, c, d. So we have our options and we will have to find out the value of the gain. Now gain is k. So we have to find out what the value of k is. Let's start with what's given to us. G of s is equal to ks by s minus 1 into s minus 4. Now since we are working with an open loop transfer function, the characteristic equation is given as 1 plus g of s into h of s is equal to 0. This is the characteristic equation, or we can call it a condition. 1 plus g of s into h of s is equal to 0. Now let's work it out with respect to what's given to us over here. We have s minus 1 into s minus 4 plus ks is equal to 0. Let's open up the brackets here. So we have s square minus 4s minus s plus 4 plus ks is equal to 0. Solving further, we get s square minus 5s plus 4 plus ks is equal to 0. Now let's find out what the expression for k is. We take everything else on the other side, we get minus of s square minus 5s plus 4 divided by s. So this is the expression for k. Now the question says that we need to find out at the breakaway point. At the breakaway point. So here is an important condition. At breakaway point, dk by ds should be equal to 0. The differentiation of the gain with respect to s will give us 0. So if we differentiate this expression here, we get dk by ds would be equal to minus of, let's see, if we divide by s here, we can write the expression as s minus 5 plus 4 by s. Now let's differentiate this here. So we get 1 minus 0 minus 4 by s square is equal to 0. So now let's equate this to 0 and find out the value of s here. So we now have, let's see, dk by ds is minus of 1 minus 0 minus 4 by s square. This is what we found. Okay, let's equate and see. We get minus 1 plus 4 by s square is equal to 0. We can write this as s minus s square plus 4 is equal to 0, s square is equal to 4, s is equal to plus or minus 2. So these are the values of s, plus 2, minus 2. But at breakaway point, we have to consider only the positive value. So this is the valid breakaway point. S would be plus 2. So we have to find the gain at s is equal to 2. So that's our next step. We need to find the gain at s is equal to 2. So here is another formula that would do good to remember. So we have the ratio. So k can be found by calculating the ratio of the product of distances from all poles to the breakaway point. To the product of distances from all the zeros to the breakaway point. Okay, now this is a ratio that you will have to remember. K is equal to the product of distances from all poles to the breakaway point divided by product of distances from all the zeros to the breakaway point. Now, if you need a clue to remember this way, it would be the denominator, the product of distances from all the zeros to the breakaway point corresponds to the numerator. The numerator and the denominator of the transfer function. This is of the transfer function given to us, okay, corresponding to the transfer function. So, according to the question, look at the transfer function given to us, Ks divided by s minus 1 into s minus 4, right? Okay, so let me write that down over here. We were given g of s is equal to Ks divided by s minus 1, s minus 4. Now, we have the value s is equal to 2. The product of distances from all the poles to the breakaway point corresponds to the denominator of what's given to us, s minus 1 into s minus 4. Substitute 2 in place of s here, that will give us the top part of the ratio of k. And this part, product of distances from all zeros to the breakaway point, is the numerator, and that is just s, because we are finding out what k is, so s remains, which is by 2. So, I will just, let me get another sheet, or I think I will do it right here, please observe. So, we have k is equal to product of distances, right. So, that is the denominator. So, that is 2 minus 1 into 2 minus 4 divided by s, which is 2. So, k is equal to 1 into 2 divided by 2, which is 1. So, here 1 is the final answer, and that matches with option A. So, I hope the generalization has helped.
Thank you for watching this video. For future videos, please click here to subscribe YouTube channel. Visit our site thesis123.com for free student project or research ideas and online training. Follow us Facebook, Twitter, Google+ and Pinterest.